Now we're going to work on part B. So on part B it said, write an integral expression in terms of T for the average temperature of the wire, first of all. And so for average temperature, we're going to use the average value equation, which is 1 over B minus A, the integral from A to B of your equation. So we're just going to write T of X dx. So that's basically the overall equation that we're going to use, but for finding the integral inside, we're going to use a trapezoidal approximation. And so what I like to do is actually draw a little chart and plot just really basic terms. Doesn't even have to be distanced properly. I just like to get an idea of the shape of things. Okay, so at 0 you have 100, at 1 you have 93, at 5 you have 70, at 6 you have 62, and at 8 you have 55, and keep in mind this is not drawn to scale. So for a trapezoidal approximation, you're going to work down and draw trapezoids. And so in doing this, it says 4 subintervals indicated by the data, and so we have 1, 2, 3, 4 shapes, and these are our intervals. And so the equation for trapezoid is 1/2 base 1 plus base 2 times height. And so for each of these, we have 1/2 for the whole thing, and then you've got the base 1 is just 1. Oops, no, that was wrong. The base 1 is 100, and the base 2 is 93, and the height is 1. And then you have the base is 93 and 70. And you have to keep in mind, even though you use the 93 once here, you have to use it again for this trapezoid also. So you use that same number twice. And then 70, and then you have a height of 4. And then you have 70 plus 62 with a height of 1 again. And then you have 62 plus 55 with a height of 2. And so when you plug all of that in, and then you divide it by 2, you can plug all that into a calculator, and then keep in mind you have 1 over B minus A, which is 1 over 8 minus 0. And so my light is getting covered up, 1 second. And so you have all of that, and then you have the area made from this. And even on the grading score, on the grading sheet, it shows that you don't have to have an answer for that, so I'm not actually going to plug it all in. But I'm just going to write 1/8 A, and then when you plug that into the calculator all the way, you get 75.6875 degrees Celsius. And so here you have to round to 3 decimal places, so I would put 75.688 degrees Celsius. And so that is going to be the average temperature, which also gives you the answer to part B. And so we did the average value equation, and then we did a trapezoidal sum to find what goes into the integral. And then you have the 1 over B minus A from the average value equation, and you put that in front of all the numbers you plugged in there, and you get 75.688 degrees Celsius.